Question number 8 is a particularly difficult limit. So that's why they've got the 2 stars there, because it's a particularly difficult one. Um, and it's probably more important to understand how we get to the limit than actually being able to do the limit yourself. So we have the limit as x goes to -2 from the negative side, and we have this log of x plus 1 function to the power of cos x. And when we actually plug it in, so if I actually plug into the limit, I get log of absolute value of -1, and this is all to the power of cosine of -2. So log of absolute value of -1 ends up being 0, and this cosine we have to the power of cosine of -2. Okay, now 0 to the power of this power here, it's not exactly clear what we're going to get. It looks like it might be 0, but it ends up not being 0. And it's all to do with the fact that it's all to do with how we approach the 0 base in the log function. So this log of absolute value of x plus 1, it's really useful to know what it looks like. Okay, so it looks like this. So this is a log of, this is y equals the log of the absolute value of x plus 1. It has a vertical asymptote at -1, and it is a mirror image across that vertical asymptote because of the absolute value. And as we approach -2 from the positive side, it looks like this. That red arrow is pointing towards 0, so that's how we get the 0 base. But notice that it's approaching the 0 from the positive side if we're approaching from -2 from the negative side. Okay, so that's very important. So what we've done is we've broken down this, and we can just kind of look at the limit of the base separately from the limit of the exponent. So I've done this here. So we're looking at the limit as x goes to -2 from the negative side in green. And this is a green graph here. And it's approaching 0 from the positive side. And then we can look at the exponent separately. Limit as x approaches -2 from the negative side. Well, 2 radians is in quadrant 3. So -2 radians is in quadrant 3. And we're approaching it in this direction from the negative side. Okay, but really we're just approaching the value of -0.41. So cosine of -2 radians works out to be negative 0.41. This is not some undefined value. We can actually go to that value. So we can actually just plug that in. So then this is what the limit looks like. We're going to approach the base from the negative side. So this base works out to be 0. However, it's approaching it from the positive side. It's not quite obvious yet why it's important that we approach it from the positive side. And the limit of the exponent as we approach from negative side, well, it's not a problem because we can actually go to that value of negative 0.41. And that's not any particular interesting value other than the fact that we do have to watch out for the fact that it's negative. That negative power affects this problem because we have a negative exponent. Negative exponents mean we're going to divide by that base. So what happens then is we end up with this expression now looking like this: 1 over 0 from the positive side of 0.41. Okay, so we're approaching 0 from the positive side. This is some exponent. Basically, we're just approaching 0 from the positive side in the denominator. Well, that means that the limit of this must be infinity. And that's how we get that infinity when we look at the graph.